angle and a central angle is really important. Make sure that you guys understand that a central angle is at the center of the circle.
You don't like when you draw circles on our notes.
Literally not. She literally.
Because then it bothers me that I can't draw a perfect circle.
No, I've seen you draw a
But then
perfect
that takes so
circle,
much more
but then
time
you
than
do
everything
that.
behind on notes.
And is congruent. I shouldn't say is congruent. And the central angle is congruent to the arc. So it's important that you guys realize that if this is 90 degrees, that this is 90 degrees only if it is a central angle, which is what we are going to be looking at today. We're going to be looking at angles that are not central angles anymore and how you're going to have to deal with those. This gets so confusing, guys. There's so many rules that you have to remember. Make sure you're studying your notes. I'm pretty sure I have like a circle tool on here. I should just use that instead. I do. I don't know how to use it though. Much better next time.
What?
That's like an oval.
I know. It's an oval tool. It's actually an ellipse is the right name for it. You're welcome.
I didn't mean to kick you. I was trying to check my
All right, so let's talk about inscribed angles. Let's talk about inscribed angles today. Shh. Please pay attention. An inscribed angle whose vertex is on the circle and whose sides contain chords of the circle. So for example here, this is different than a central angle because the vertex is now sitting on the circle rather than at the center. You guys see the difference there? So, angle, that's a circle tool still. Angle ABC is inscribed. Vertex B is on the circle. So you know that that is inscribed because vertex B is on the actual circle. I believe you guys have a quiz on Thursday.
And then we're off Friday, right?
Yeah, sorry guys, 1 second. While I'm using my computer, that's going to disappear.
And then next Monday, Tuesday as well.
I'm going to look real quick. If that's the case, then probably.
This is the reason why I went for it.
Wednesday.
Is that what she sounds like? Is that
Is that what I sound like?
Teachers sound like that.
Did I sound like that?
That's what all teachers sound like.
Oh.
Miss Maddie, you don't sound like that.
Yeah, you have a quiz, which means you guys have no homework. So quiz Thursday, guys. Quiz Thursday, no homework over break.
You don't even know what it is.
Yes, I do.
You don't.
Yes, I do.
So quiz Thursday, which means no homework over break. Oh, you're right. All right, so an intercepted arc is an arc that lies between the two lines, rays, or segments. That should say segments. It got cut off. So the intercepted arc is arc AC. So you see that it is connected by the other 2 points of the angle. So the non-vertex points of the angle create an arc in the circle. Do you guys see that arc that it's creating?
Yeah.
So it's important to understand where that is. So here is the theorem. The measure of an inscribed angle is 1/2 the measure of the intercepted arc. So the measure of angle ADC is equal to half the measure of our arc AB. Guys, please stop talking. So it is important that you guys see that this is not the same. So when it's a central angle, they are the same. When it is an inscribed angle, it is half. So this measure here is 1/2 the measure of AB. And it can be looking in any way. One of the chords could be the diameter, the center could just be in the center of the arc, and the other, it could not even go through the center. Yes?
Shouldn't the angle in the equation be ABB to ABC?
Yep. Here I go again. ADB, right? So that should say ADB, guys. Thank you. All right, so let's look and get some examples done here. Thank you, Katie.
Sorry, get ready. I'm thinking of.
All right, so find the indicated measures. We're going to find the indicated measures in our diagram. So it says find the measure of angle T. So we need to know what the intercepted arc is. What is the intercepted arc of angle T? Arc RS. And we just learned what the relationship was. What did we say the relationship was? The angle is half the arc, right? So we know that the measure of angle T is 1/2 the measure of arc RS, which is its intercepted arc. So we know that RS is 48. So what did you say it was, Greg? 24. So the measure of angle T is 24. So you may not need to write all of these steps down, but this is good to write down for notes so you know where that came from. The inscribed angles tells us that the angle is half the arc. So that's why I wrote that down, and then I was able to substitute in to get that done. So arc QR is this arc here. So we're going to have to do some work to figure out arc QR. So let's look at this a little bit here. I don't even know that you can find arc QR. Let me look at this real quick. Let's switch that to arc QT. Switch that to arc QT. That should say QT. You can't find the other one. So find the measure of arc QT. You don't have enough information for QR. So we're going to find the measure of arc QT. So QT is that arc there. What is its angle? What is its angle? R is its angle. So we are going to show a relationship with R and the arc. So you've already said the answer. That's true. Measure of angle R is equal to 1/2 the measure of angle or arc QT. Well, the angle is 50 this time. So what are we going to have to do on both sides to solve? Divide by half or multiply by 2 would be easier, right? So we know that the measure of arc QT is 100. Greg, did you really have to do all that work to get to your answer when you said it? No. Most of you guys will figure out this relationship and you'll be just fine. All right, find the measure of arc RS and the measure of angle STR. So RS should be pretty straightforward for us to find first. What angle are we going to look at? There's two that we could use. What two angles could we use here? Yeah. What's the other angle you technically could use, but it isn't giving you enough information at this point? STR, do you see how both of them intercept that arc? Do you guys see that? It just doesn't give us any information, so that's why we're not going to use it. So we know the measure of angle SUR is 1/2 the measure of arc SR. SUR is 31. So how can we solve to figure out what the arc measure is then? We multiply by 2. So that means the arc measure is 62 degrees. Could we find angle STR now? Now that we have that information, could we find angle STR? Look at that, and if you think you can, raise your hand and tell me what we need to do. Yeah, Katie? You mean, yeah, so you're multiplying it by half, right? So the measure of angle STR is equal to 1/2 arc SR, right? So arc SR is 62. Half of 62 is 31. What do you guys notice about those two angle measures? Why would they be the same? Why does that make sense? Think about that. Why does that make sense, Cameron? Right, they intercept the same arc, and we know there's a relationship between an inscribed angle and their arc, right? So if it's the same arc that they're intercepting, shouldn't it mean that they're the same, right? So that makes sense. So there's a theorem on the next page we're going to use, but we do notice that they are congruent. So when you're ready, flip so I can move on. I don't want to. Okay, inscribed angles of a circle theorem. So this is what we were just talking about. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. So do you see how these both intercept arc AB? Are these both intercepting arc AB? So both angle D and angle C intercept arc AB. Therefore, angle D is congruent to angle C. So if those intercept the same arc, they are congruent. Yeah.
Would it also be intercepting these DC like the there?
Like the segment?
No, the arc.
No, that's a different one. Well, I mean, they both do intercept that one, so yes, DC could also be congruent. Yeah. And that would mean that A and B are congruent as well, if that's what you're looking at, yes. Okay, so given that angle E is 75 degrees, find the measure of angle F. So instead of doing all this work, do they intercept the same arc? Do they intercept the same arc, guys? Yeah, so do we have to do any work, really? No, what do we know what the measure of angle F is? So, since angle E and angle F intercept arc GH, angle E is congruent to angle F. That's why we can just automatically say that at angle F is 75 degrees. And then we're going to have some more theorems to look at here. Okay, so some other theorems. What is an inscribed polygon? An inscribed polygon is a polygon with all vertices lying on a circle. So if you're drawing a circle, it actually looks like a circle, and you draw a shape inside of it, all of the vertices are on the circle. Do you guys see that? All vertices are on the circle. It is not inscribed if one of them are not on the circle. Circumscribed circle is a circle that contains the vertices of an inscribed polygon. So again, it means basically the same thing, just a different way. Circumscribed just means it goes around the circle. So a circumscribed circle goes around the vertices of the circle. So it must touch every single vertice. So an inscribed right triangle theorem. One side of an inscribed right triangle is a diameter of the circle if and only if the triangle is a right triangle and the angle opposite the diameter is a right angle. Notice this is if and only if, which means it can be read both ways. So, if AB squared plus BC squared equals AC squared, then AC is a diameter. So if you take those sides and you square them, and this is the diameter, the one that you're presuming to be the diameter, then it better equal that one. And it can be read the other way. If AC is the diameter, you know angle B equals 90 degrees. So if it is the diameter, you know that has to be a right triangle already. So you know that angle B is 90 degrees. Which leads us back to that problem. Remember when I told you guys to change that problem? We could go back and do that problem now. The problem was where it was located in the packet. I hadn't taught you guys that part yet. So if we wanted to go back, we could do that. I don't think I'm going to, but we could easily do that problem now that we know that it's a diameter. The problem was that just wasn't there yet. Inscribed quadrilateral theorem says a quadrilateral can be inscribed in a circle if and only if its angles are supplementary. So opposite angles must be supplementary. So the measure of angle E plus the measure of angle G equals, what does supplementary mean? How many degrees? 180. And the measure of angle D plus the measure of angle F equals 180. So just be looking for the situation. Just be looking for the situation where this is a diameter. And let's talk about why this has to be 90 for a second before we move on. So if you see that it's a diameter and you see that the chords are connecting to the diameter, do you guys see that? Think about this. How many degrees is this arc? It's a semicircle, so it's 180. What's half of 180? And that's why this is always 90. No matter where you move this B, it's going to be intercepting a semicircle, and half of a semicircle is 90. So that's why that angle is always that way. So be careful to look for those situations where you have the diameter being intercepted so that you can see that it's a semicircle and half of 180 is 90. So it's always a right angle. All right, so is AB the diameter? Yeah, it has the center point, so that's why we know it's a diameter. If that center point isn't there, we don't know that. We know that the arc, when it's intercepting a diameter, is 180 degrees. So half of 180 is 90, which means 2x equals 90. So what is x? Go to class. Go away. Shoo. What's half of 90? 45 degrees. Or just 45. Casey, are you okay? Your facial expressions are just... Where are you... So, you know that this is intercepting this diameter, right? You see how that's half the circle?
What is this?
Well, the angle itself is, yeah. You see that this is like taking in both
Yeah.
points, so it's intercepting the semicircle. What is the
Okay.
semicircle? How many degrees?
180.
And you know that the relationship between the inscribed angle and that is
Half.
half of 180 is,
Yeah, 90.
so that has to be 90. Does that make sense?
Yeah.
Anybody else like super lost and confused? Okay, what does the inscribed quadrilateral theorem tell us? What does the inscribed quadrilateral theorem on the previous page tell us? Yeah. Opposite angles equal 180 degrees. So Z plus 80 equals 180. And Y plus 120 equals 180, right? Opposite angles must equal 180 degrees. That's what the inscribed quadrilateral theorem tells us, as Cameron said. That's the only way you can inscribe a quadrilateral into a circle. It has to have opposite angles supplementary. So that means the measure of angle Z is how many degrees? 100. And the measure of angle Y is, all right, notes done.